In this video, we're going to focus on the 15 minerals that you're going to need to know. Now, hopefully you remember what an element is, and you are able to distinguish that from what a compound is. Now, remember, an element makes up a single atom, or it can be many atoms of a single pure substance, and that cannot be broken down into a simpler substance. Compound is actually going to be multiple atoms or multiple elements combined to make a new substance. Through a chemical bond, it has new character traits, and so that's going to be more than one element, more than one atom. Now, minerals can be made up of a single element, and those are going to be called native elements, or they can be made up of compounds. Now, they are not going to be a mixture. When we talk about mixtures, that's going to be referring to a rock. A rock is a mixture of minerals. But minerals, primarily a single element, which is a native element, or a compound. Now, the definition of a mineral, which we're going to focus on a little bit in the future, in about a week, a mineral is a naturally formed, so it's found in nature, inorganic, so it doesn't have carbon and hydrogen in it. At the same time, it's not organic. It's a solid, so it can't be a liquid. So technically, ice in room temperature melts. So ice wouldn't be considered this. And it has a definite solid shape, and it can be found in a crystalline form or structure. So minerals are natural, they're not man-made. Minerals are not alive. Okay, they don't have carbon and hydrogen, so they're inorganic. Minerals have a definite shape, so they're a solid. Minerals are made up of elements, so they have this unique chemical makeup, this element or compound structure. And then minerals are made up of particles that have a repeated pattern that kind of grow and develop in this crystal shape. Now, how do minerals form? They can actually form two different ways, by the cooling of magma, or minerals can form by being dissolved in liquids. When minerals are cooled in magma, if there's a fast cooling, no crystals will form. This is perhaps a good example would be obsidian. Obsidian called volcanic glass. There's no crystals there. But then you have, if there's a medium cooling or a slow cooling, you might have some crystals such as granite. Okay, just like with our element flashcards, you're going to put the mineral name on the front, and then on the back, write the mineral symbols and the facts. Now remember, these mineral symbols may just be an element, which you may have seen on the last index cards, or these may include a long compound, including many symbols. Okay, here's our 6 native elements. We have copper, which was Cu. You can go back to your element flashcards to write these down. You have gold, which was Au. Then we have graphite and diamonds. So number 3 is graphite, which is carbon. And you can actually do some research on graphite. You can write down that graphite found in pencils. It creates a grayish streak. For diamonds, also carbon, very valuable, used in rings and jewelry. Has a very strong hardness on the hardness scale. Then we have silver, which was Ag, and then we have sulfur. So you can go back to your element flashcards or even use Google to help you find some of the facts for those. Now I'm going to jump to your first compound, which is quartz. Now quartz is a silicate, and silicates have silicon in it. So quartz is actually going to be called silicon dioxide. So write quartz on the front, and then on the back, I want you to write silicon dioxide or SiO2. Now, if you write SiO2, make sure you know SiO2 is silicon dioxide. Di meaning 2, so it has 2 oxygens. So this is a compound, silicon dioxide. Quartz is found in mirrors, optical lenses, drinking glasses, the little timepiece in watches, and also sand. And sand with heat forms glass. Then we have talc or talcum powder. Talc is actually used to be used as baby powder, but they're finding that it has harmful effects. Can be found in plastic, paints, paper, and ceramics. It is the softest on the mineral hardness scale. While diamond is the hardest, talc would be the softest. And you can see the element symbols. We have magnesium, we have silicon, we have oxygen, we have hydrogen. And so this is a compound that involves many elements. Then we have mica. Now, I'm not going to put the formula on here, so you don't have to worry about writing that empirical formula of the symbols. It's just way too large. It's a lot larger than talc. But mica has something called cleavage, meaning it can easily break or separate in layers. And you're going to take a look at mica. It can be used as electrical insulators, can be used to create this shiny, pretty eyeliner or eyeshadow, can be used in blushes and other makeup. Now we're going to go to some non-silicates, so it doesn't have silicon, but these are primarily called oxides, meaning they have oxygen in them. We have hematite. Now hematite is going to be a metal that's going to primarily have iron in it. So hematite is commonly known as iron oxide. Hematite or iron oxide can easily rust when it's oxidized. Now hematite is used in door handles, door hinges, metal bed springs, the metal bands on watch, and other household items that include a metal structure. Then we have chromite. Chromite is pretty cool because it has iron and oxygen, but it primarily has chromium in it. And that third element gives it a new character trait that separates it from iron oxide. Iron, chromium, and oxygen, hence the name chromite. It can be ground up to give different colors, and used in different dyes for dyeing clothing, maybe bed sheets, and different things that you want different colors, such as rugs, bed sheets. Now we have ice. Ice is an oxide, right? It has hydrogen and oxygen. Well, why is ice not a mineral? Some scientists say it is, some scientists say no, and we're going to say no because it's not going with the definition of a mineral. It's not a solid at room temperature. Now let's move to halides. Halides, specifically halite, is a salt. Now, this can be table salt, this can be rock salt, this can be salt used to de-ice roads, can be used to preserve food or add flavoring to food, or even soften water if there's too much other minerals in the water. And then we have fluorite. We talked about fluorite before. Fluorite can glow in the dark. It can be used as fluoride in toothpaste and drinking water and help with industrial steel making. Now we have carbonates, which contains primarily carbon. We have calcite, which is primarily known as calcium carbonate or chalk. It can chemically change into limestone, which becomes very brittle. Now there are other non-silicates such as sulfides, which has sulfur, sulfates, phosphates, which has phosphorus, and hydroxides. Now we're going to focus on copper sulfate, and we have copper, sulfur, and oxygen. And we know copper is an orange color, sulfur is a yellow color, and we know oxygen is a colorless gas. Well, you bond those together. Remember, each of those elements have different character traits, but when you bond them together, it forms a new character trait. Copper sulfate primarily is a whitish powder, but when bonded with water, it can actually turn a bluish color or even a blue crystal. Calcium sulfate has been used to kill fungi. It can be used as a fungicide, can be used as an insecticide to kill insects, and also used to kill mollusks, which would be your soft little animals, soft-bodied animals such as snails and slugs. Now here's a little bonus. What we have here is turquoise. Turquoise is, as you can see, very long empirical formula, also bonding with water. It has copper in it, and that may tend itself to this bluish green color, this mineral. Very beautiful color used in jewelry and statues.